Welcome back to Water Quality in the Pacific Northwest. We're covering our last unit today, and we're talking about waste and trash and its relationship to water quality and pollution. This is a set of 3 lectures where we have talked about wastewater treatment in units 38 and 39. In lectures 38 and 39, we covered septic systems in unit 39, and today we're taking a look at the solid waste portion, the solid waste that we dispose of. So this is lecture 40, the last lecture of the class. Even though most solid waste is landfilled or burned, a portion of these pollutants end up in the water, and that is because of improper incineration or improper landfilling. A portion of that waste can leach or leak into the water systems and thus contaminate and degrade water quality. Because of that, solid waste has a significant impact on water quality, and it's something we should finish the course up with. Solid waste impacts on water quality is different in different areas of the world. Trash in third world countries, where we don't actually specifically landfill the trash or have an organized way of getting rid of our solid waste, a lot of times this waste directly enters our water body and pollutes surface water. When we have landfills, if the landfills are not built properly, the leachate can go through the landfill and enter groundwater, which can then enter surface water. And also with incineration, if you don't incinerate solid waste correctly, you put materials in the air that will wash down in the rainwater stream and may pollute water. So let's take a look at solid waste, the crisis and management in highly developed countries, and specifically the Pacific Northwest. Basically, we refer to our solid waste that we throw away in cities and towns as municipal solid waste. It's abbreviated as MSW. It's a total of all materials that we throw away as solid trash. We throw a lot of solid waste away as trash in the United States. On average, the average person throws away 4.5 pounds of solid waste per day. That's an equivalent to over 75,000 garbage trucks full of solid waste a day, or well over 220 million metric tons a year. And that's just here in the United States. A lot of people have looked at the solid waste that we throw away, and we can categorize that waste into several categories. On average, if we take a look at our trash, about 37% of our trash consists of paper products. 12% consists of yard waste. 11% consists of food waste. Another 11% we can classify as plastics. Another 8% can be classified as metals. Another 6% can be classified as glass. 6% can be classified as wood materials. And the other 10% is a miscellaneous combination of different types of trash. So if you take a look at those trash values and those different components of trash, well over 80% of that trash is fairly easily recyclable. So we could be recycling a lot more of our solid waste stream than we do right now. If we take a look at disposal of solid waste in the United States, we've evolved. We've evolved from open dumps. We used to take our trash to a dump, and that dump was burned, or the trash in the dump was burned. That caused air pollution. As we threw away more and more trash, municipalities got bigger. The open dumps and burning changed to incinerators, where we could burn large volumes of solid waste at higher temperatures. However, when the Clean Air Act was passed in 1970, one of the major air pollutants was burning of trash. Consequently, we moved away from depending on incinerators to dispose of our trash to using landfills, or what we call sanitary landfills. If we look at the current disposal practices of solid waste in the United States, these are roughly the numbers today. About 55% of the solid waste Americans throw away ends up in landfills. Another 15% is incinerated in special incinerator plants. And we recycle a little bit more than 30% of our trash. That recycling number has been increasing over the years. We're probably up to 32, 33%. We gain 1% in recycling probably every 2 to 3 years. Clearly, we're moving toward a more recyclable or more sustainable trash disposal system, but we're not there. Still, over half of our trash ends up in landfills. So since over half our trash ends up in landfills, we need to talk about the relationship between landfills and water quality. Today, the landfills that are permitted across the country are called sanitary landfills. And these are landfills where we dump solid waste, and every day at the end of the day, that solid waste is covered with a layer of soil or dirt to reduce the vermin and to reduce the potential of odors. Now, we've used landfills in the United States for a long time, but sanitary landfills are relatively new. In addition to covering trash that we put in landfills on a daily basis, traditionally landfills were sited by convenience. If there happened to be a gorge or a cavern, low spot in your general municipal area, we cited that as landfill because we throw everything downhill. But that's not really good because usually it's the lowest spots in the landscape that are closest to the water source and can cause the most water contamination. Today, locations or siting of landfills are based on environmental criteria, and one of those major criteria is to keep the trash as far away from a water source as possible so that we do not contaminate our water source. If we look at other highly developed countries in the world, they have the same problem. They have a solid waste crisis. They don't generate quite as much trash per person as we do in the United States. But if we take a look at a few other highly developed countries quickly, let's look at Japan, highly developed country in Asia. About 60% of the trash, the solid waste that they have in Japan, is combusted or incinerated. Another 20% is recycled. That means only about 20% of their trash is landfilled. And that's simply because there isn't a lot of land available in Japan for landfills. Landfills take up space. Consequently, the government of Japan has been pushed to combust or to incinerate as much of their trash as possible. Also, the Japanese are not as good as Americans as far as recycling. We recycle 33% in the United States compared to only 20% in Japan. However, you could also add that people throw away less in Japan. If we go to Western Europe and we look at the major countries in Europe, the United Kingdom, just a couple quick pictures. Here's a sanitary landfill where the trash is brought in. It's laid down. At the end of the day, a layer of soil is put over the trash to reduce the odor and the vermin. Next day, they bring more trash in. They keep on building up the trash layer until the landfill is full. Landfills are pretty much the same across the country. Again, we are talking about sanitary landfills that are designed and planned so that we can protect the environment, particularly protecting water quality. Here's another example of a landfill, probably something that we see more often across the country because a lot of this trash is in plastic bags. In some areas of the world, we have mega landfills. There's a landfill, I believe it's either in Singapore or Hong Kong in Southeast Asia, where there is not a lot of space to build landfills. Here you can see basically a valley between two mountain ridges basically has been set aside as a sanitary landfill. The trash will be piled in here, and eventually this landfill will be as high as the ridges on each side, and then they have to find more space for another landfill, which is difficult with a limited land base, and that's why a lot of countries are going toward incineration. If we look at trash disposal in the less developed countries, in less developed countries, a significant portion of trash is taken by individuals to dumps. Some of these dumps are very large, and usually there is no environmental protection associated with these dumps. There is no way to protect runoff from the surface of these dumps from entering the water body. You actually have people that live in the dumps or make their living off the dumps. They're basically human recyclers. They pick through the trash, take out what they can to sell. Sometimes when the dumps get overwhelming, they're burned to lower the level of trash and to make room for more trash. As you can see in this particular burn, there's a lot of air pollution associated with it. So there's a lot of problems associated with traditional landfills, particularly in less developed countries. So in less developed countries, a significant portion of the trash is taken to dumps. However, when it rains in these dumps, and a lot of these areas are tropical countries where it rains pretty heavy, lots of rain. When it rains, the leachate, the water that moves through this trash, can run off the land into rivers, polluting rivers, can leach into groundwater, polluting groundwater, which may be a source of drinking water. And basically, these uncontrolled landfills are a significant source of water pollution in countries. So this trash that's taken to the dump, a portion of the trash is burned, just simply open burning in these large dumps in less developed countries. The burning occurs at low temperatures, so you get an incomplete combustion or an incomplete burning of the trash, and that puts a lot of waste products into the air that can eventually end up back on the land, or you create ash in the landfill, which runs off the land and pollutes the waterways. So the unburned trash blows around and eventually pollutes the water. What doesn't get burned can blow around and eventually pollutes the water. So it's a major source of water pollution in less developed countries. Now, not everybody in less developed countries takes their trash to a dump. A lot of people just throw their trash out their front door, and you end up with a situation where you have garbage all over the landscape. The garbage eventually starts to decompose, or it's moved off the land by processes like rainfall and things like that, so that the garbage eventually pollutes drinking water sources. The tossed garbage just outside a home ends up eventually in rivers and then pollutes them. A particularly bad part of the garbage that's thrown away in less developed countries is the organic portion of garbage. The organic portion of garbage it eventually partially decomposes, then it can leach and pollute groundwater. So we have a lot of problems associated with solid waste disposal in less developed countries, and it's a major source of water pollution, particularly drinking water pollution in many of these countries. So let's spend a little bit of time looking at disposal of trash in developed countries. Again, about 55% of the trash we throw away in the United States ends up in landfills, and about 15% is disposed of by incineration. So let's take a look at the landfills. Well, there are several problems associated with disposal of trash in landfills. If the landfill is improperly developed, it's improperly maintained, leachate can leave the landfill and negatively affect water quality. Okay, we start with a sanitary landfill. We're piling trash up in the landfill. It rains. and the landfill is still open. Rainwater moves into the landfill and it moves down through the trash. This water, which was pure water as rainwater, as it moves down through the trash, it starts to decompose parts of the trash. Things in the trash liquefy, and you generate a leachate, which is pretty noxious, pretty toxic, and that can cause groundwater contamination. So that's one of our major problems with landfills, particular problem when we're talking about water quality. In landfills, trash eventually starts to decompose. As it decomposes, most of that trash is organic. It produces methane. And methane has to be properly disposed of or used, or it can cause explosions. Landfills aren't built for trash to decompose, so you get a poor decomposition situation with most of the trash in the landfill. Consequently, landfills never go away. You fill up a landfill, you close a landfill, that space is always going to be required for the landfill, and then you have to go and find another piece of land to develop a new landfill. So you're using more and more land over time. Now, you get a little decomposition in the landfill, not much, but as things start to decompose, the land will settle a little bit. So the closed landfill is not a good place to build homes or structures on because foundations will crack. So those are many problems associated with modern landfills. Let's look at each of those issues in a little bit more detail. Let's start out with the leachate generation. Leaching is simply water moving through the landfill. As the rainwater, moves through the landfill, it dissolves chemicals in the trash and creates a leachate. Most of that time, that leachate is what we call a noxious leachate. It's nothing we want to have come in contact with our drinking water supplies or with our rivers. Because what we pick up as the water moves through the landfill, you've got decomposing organic materials with paint, metals, bacteria. In some states, up to 10% of a landfill's mass are disposable diapers, are used disposable diapers. You don't want water running through those used disposable diapers because you've got a noxious leachate that if it gets into our water supply will adversely impact human health. So we've got to protect that. Okay. Methane generation. When some of the trash starts to decompose in a landfill, methane is produced as part of the organic matter decomposition process. Methane will leak out of the soil. It will move upwards into the air. Methane moving through soils can kill plant roots. It can cause explosions if you have high concentrations of methane. On the positive side, if you have a modern landfill, you can put in a piping system to harness the methane, which is basically natural gas, and use that methane as an energy source. Sell it to your utility or use it to help maintain the operation of the landfill. The third issue I mentioned is poor decomposition. We've got materials in the landfill that are pretty inert. We talked about plastics in the ocean. We know plastics are pretty inert. We throw plastics away. Paper, which is organic, which should be decomposable. Under the right conditions, that paper would decompose, but it may not be in the right environment for decomposition because the way we build a landfill, we're not trying to get things to decompose. We're trying to wall off this trash from the environment. So that's the third problem. And the fourth problem is settling. As things start to decompose in the landfill, the land settles a little bit, and that makes it pretty undesirable to build structures on the surface of a closed landfill. You can't build a subdivision. You can use that old landfill surface for things like parks and recreation where you don't require foundations. So one of our challenges is, in the United States, we throw the majority of our solid waste away by using landfills. So governments particularly the EPA, has spent a lot of time and effort in trying to improve landfills, to make landfills safer. The big issue with this, we can make landfills safer. We can provide a lot more protection to waters. But are we really trying to fix the wrong answer? Landfills are really not the long-term solution to our trash problem. Recycling is the long-term answer to our trash problem, or maybe throwing away less is the long-term sustainable solution. So we're basically spending lots of money, lots of effort on trying to make landfills safer, but in the long term, landfills shouldn't be part of the equation. We're trying to fix the wrong answer. So there are relatively recent design features that have been proposed and that are used to improve landfills. And I'd like to go through some of those things that are required in the process of building modern landfills. The first thing is siting. The landfills have to be located high above a water table, not near a water source. So if you physically can remove the landfills from water sources, you've done a pretty good job, at least initially, in protecting water quality. The second thing to improve a landfill, which is required of all modern installations, is to capture any water that leaches through the landfill while it's opened. And that would be putting in a leachate collection system with drain tiles and liners and things like that. The best way to demonstrate that is by looking at this diagram right here. Here we have a modern landfill. You can see there's trash in cells. Every day, trash is delivered to the landfill. It's covered by soil. And the landfill eventually takes on a kind of a pyramid shape so that if rain comes and hits the ground after the landfill is closed, the land kind of sheds the water. But basically what we do at the bottom of a brand new landfill is we put in a system that prevents leaching. We have a liner, a plastic liner, as you can see where my arrow is, at the bottom of the landfill. This plastic liner is about as thick as a rubber tire. It is supposed to protect water or prevent water from moving through. Right above the liner, we have gravel. Within the gravel, we have pipes, perforated pipes, so that if we have some water that falls on the top of the landfill and it leaches through all this trash, it becomes a noxious leachate. It moves down into the gravel. From the gravel, it's fed into these perforated pipes, and from these perforated pipes, that noxious leachate is moved off-site into a treatment pond where that leachate can be treated and protect the environment. So we have a drainage system. It's pretty complex system. It works pretty well if it's designed good. Again, if you take a look at this diagram of a landfill, you can see that the landfill is sited well above the water table. So that's the first thing that protects the environment. The second thing is this leachate collection system with a liner, gravel, perforated pipes that would move any water that would get into the landfill off-site, and then that can be treated. So the refuse or the trash is positioned in a pyramid shape so that when the landfill is full, we basically have a pyramid shape, and we put a plastic liner on top of the landfill. And basically you're creating a lens in the landscape where you have plastic below the landfill, plastic liner above the landfill. It rains, the water is shed off the landfill so it doesn't move through the landfill and become a noxious leachate. In addition, monitoring wells are required. Around the perimeter of the landfill, monitoring wells are drilled into the local groundwater, and that water is monitored continuously to make sure that the landfill has not contaminated the groundwater. If contamination levels are picked up, the municipality has to go in and repair the landfill to prevent leaching, and that can be a huge expense to local taxpayers. Taking a look at another diagram of a landfill, pretty a similar type diagram. Here you have the soil. You have a liner right below this orange level right here. You see the liner that's right there. Then you've got gravel. In that gravel, you have these perforated pipes, which will pick up any water that goes into that gravel. So you've collected the leachate from an open landfill. That's pumped off-site to be treated. This landfill is located well above the aquifer, which is this lower layer right here. You have a monitoring well. And then you have the leachate, as it's collected in the pipes, is moved to a treatment facility where you either evaporate the leachate or you treat it. And here is a vent to collect any methane made by decomposition of the trash in the landfill. You can capture that methane, send it to a utility, and use some of the money you get from that methane generation to offset the costs of the facility. So again, some of the components of a modern landfill: siting. Site the landfill as far away from an aquifer or a water source as possible. Second, put a liner at the bottom of the landfill and have a leachate collection system to collect that noxious leachate. Position the landfill so that it can look like a pyramid when it's filled. And the pyramid shape will help shed water. After the landfill is filled and decommissioned, water will hit the top of the landfill and be shed to the surrounding land. That landfill will be capped when it's closed, so the positioning and the capping will help it shed water, reduces water infiltration, produces less leaching. And monitoring wells are required, so you can check to make sure that the local water sources are not contaminated. These monitoring wells have to be checked regularly because basically new landfills never go away, because the landfills aren't built so that the trash decomposes easily. So there is minimal decomposition, and a lot of people would say that's a wrong answer. The longer a community exists, the more landfills you fill up, and eventually you have several landfills in your county, and that's a taxpayer expense because you're always monitoring wells, and the trash itself is a liability. If it starts leaking into water systems, taxpayers have to foot the bill to come back and clean it up. Now, there are federal restrictions. There's local restrictions. You have to build landfills in suitable geologic areas. You can't build them on faults. You can't build them on wetlands. You're not supposed to build them on floodplains. So these are all part of proper siting. The liner requirements: it has to be a flexible liner on the bottom of the landfill over compacted clay, and this is done to collect the groundwater. Right above the liner, you have a leachate collection system, which is gravel and perforated pipes. So if water does leach through the ground, the landfill, that liquid can be collected and removed. And that leachate collection system is located right on top of the bottom liner. And it's designed to remove any leachate from the landfill. If you collect leachate, you've got to be able to take that leachate out of the bottom of the landfill, and you need to treat it. It needs to be removed to another site, and it needs to be treated so that it isn't noxious. Again, I had mentioned earlier that the operating practices of a modern landfill are that you put the trash in the landfill every day, and then you compact the trash, and you cover the waste frequently with layers of soil to reduce odor and to reduce vermin. The compacting the trash frequently and the soil layers help control litter, insects, rodents, and basically what it does, it protects public health. And again, the federal requirement requires monitoring groundwater wells that are built in the local area just for the landfill, and they have to be monitored indefinitely. When the landfill is full, there are restrictions, federal restrictions and regulations on how the landfill has to be closed and what has to be done after closure. You have to cover the landfill, and then you have to provide long-term care of the landfill, and that is a liability for the local county, municipality, the taxpayers within that system for a long time. So that's why landfills are probably not a sustainable solution. Our sustainable solution, again, is probably a combination of reducing the amount of trash we throw away and almost 100% recycling. Now, if you close a landfill and you start seeing problems in the local water quality, the federal government requires that corrective actions be taken. You have to go in and clean up the landfill releases. This will help the groundwater quality, but it is a very expensive process. The federal government requires that the local municipality provide funding for environmental protection during, use, and after closure. And most of this environmental protection is associated with water quality. So bad landfills can greatly negatively impact water quality. And we have lots of old landfills around the country that were grandfathered into these new rules and regulations. So in some areas, they can be ticking time bombs for local water quality. The other main method of disposing of our solid waste is by burning the trash, incineration. We have 130 major facilities in the United States that incinerate trash. We call most of these plants waste-to-energy plants, which means we burn the waste, and in the process, through the heat of combustion, we create energy, which is then sold to the local utility to offset some of the incineration costs. So we have 130 incinerators in the country. 110 of the 130 facilities are actually waste-to-energy plants. And that includes, in the Pacific Northwest, the big waste-to-energy plant in Spokane. Spokane County, which has about 470,000 people, collects all solid waste in the county, and all of it is incinerated. Here's a picture of the outside of the waste-to-energy plant in Spokane, Washington. It's located at about mile marker 276, just west of the city of Spokane. Public is always welcome. They provide tours of the waste-to-energy plant. This happens to be a tour group from an introductory environmental science class. You go into this facility, and it's a huge facility. All the trash trucks that collect trash in Spokane County bring their trash into the waste-to-energy plant and dump the trash. With 470,000 people, you're generating a lot of trash every day, and this waste-to-energy plant needs a large volume of trash to make the process pretty efficient. This trash is mixed continuously so that you have a uniform type of trash. And basically the trash is on the ground here inside the facility, and you've got these big cranes that move the trash, pick it up, and move it over to the incinerator. Again, you can see a crane picking up trash, mixing it, and then it will pick the trash up and move it over. Here's a picture of some college students going through the plant. You can't get that close to the incinerator, but there are some glass windows that you can see what happens. Trash is picked up from the floor of the waste-to-energy plant, and it's put into the incinerator, and it's burned at a very, very high temperature. When you burn at a very high temperature, you create a lot of heat, and this heat can be changed into energy, which goes on the power grid to offset some of the cost of having a waste-to-energy plant. One of the neat things I think about the waste-to-energy plant, you can argue pro and con. It's basically a personal belief whether you think incineration is a long-term solution. A lot of people that don't like incineration as a long-term solution would say you're burning a trash resource that maybe someday could be reused. One thing that I think that's kind of interesting is they burn the trash to a point where they basically get an ash. But after they burn the trash, they run magnets through the ash that they create. And this happens to be metal that they've reclaimed from the ash after they burn the trash. So they can reclaim, they basically can recycle the metal, can take it out and bale it and sell it on the market. The waste-to-energy plant is a pretty complicated system. Here's a diagram of how it works in theory. Here we have the inside of the waste-to-energy plant. We have trash trucks coming in. They're dumping their trash. And then basically we have a crane that will come down, mix the trash, pick the trash up, and put it into the hopper so that it goes into the boiler where the ash is burned, where the trash is burned, and you're left with ash. As you've got the heat of the burning, you've got heat exchangers, which basically heat creates energy, which you can basically use the heat to spin turbines for a generator, and you can put that energy that you create on the electric grid. When you're burning the trash, you've got to be worried about air pollution, so there's a lot of steps and filters to make sure that the air quality is protected and that you're not getting rid of one problem, the trash, and creating air pollution. An efficient waste-to-energy plant produces very little air pollution. So some people would argue that incineration is better than landfills. The pros of incineration is you reduce the weight and volume of trash you collect. You collect it, you burn it. The burning process reduces the volume and the weight of the trash by 90%. If there are toxic or hazardous substances in the trash, they're concentrated into only about 10% of the volume, the original volume of the trash. You don't need any special procedures to collect trash. You just have the trash trucks go down through the neighborhoods, pick up everybody's trash, and bring it to the centralized plant where it's burned. The modern incinerators, which we call waste-to-energy plants, are designed to generate electricity, and they're sold to offset costs. Well, all of these things are nice about incineration, but there are some cons. The trash may not burn cleanly. If it doesn't burn cleanly, you've got some problems with potential air pollution. The facilities are very expensive. Spokane got a waste-to-energy plant because it got a couple big grants to build the facility. It costs a lot more than landfilling. And no one really wants to live near a waste-to-energy plant. Then your other problem is, even though you burn the trash and you reduce the volume of the trash by 90%, you've still got that 10% that you have to landfill. You have to dispose of it in a secure landfill, and that ash that's left may be concentrated with toxic or hazardous waste. So even though you have a much lower volume of stuff that you still have to landfill, it's still a problem. So the ash has to be disposed of in secure landfills. Not every community can build an incinerator because you need a continuous supply of trash to make the incineration process efficient. And another con of a landfill or of incineration process is electrical generation wastes both energy and materials. However, if you incinerate your trash and you landfill that 10% of the trash volume that's still there in a secure landfill, you're doing a pretty good job at protecting water quality compared to our traditional landfills. So I just wanted to make you aware that disposal of wastes, our liquid wastes in units in lectures 38 and 39, and our solid waste here in unit 40, are an important component of water quality in the Pacific Northwest and worldwide. Thank you very much for your attention. France, Germany, about 50% of the trash, solid waste they generate, is combusted and or recycled. And of all that trash, more than 20% is recycled. Again, a lower recycling rate than the United States as a whole. However, there are specific European countries such as Austria where the recycling rate is actually higher than in the United States. So basically, all highly developed countries have a trash problem. How they approach that trash problem is a little bit different. Okay, many of us have been to our local landfills. Many of us have seen landfills.